Okay, so new day, new new learning experience. So I think what I can do, because looking at it, that the following exercise, I think up until maybe iterator, no, up until lifetime, we haven't learned iterator yet. Up until lifetime, they are all okay that we have read the book, except this little bit here for enum. So I guess what we can do is to quickly read that little like 18.3, and then we can move on with more rustling exercise. Last time we finished all the struck here. We are a quarter into our journey, so yeah, let's try to read this a little bit, and then we can move on and do some more rustling exercise. So 18.3, it seems very far, but what does it mean? Let's talk about pattern syntax. So we just need to read this a little bit, then we can do the enum exercise maybe. In this session, we gather all the syntax valid in Platons and discuss why and when you may want to use one. So it's more about pattern matching, matching literals. Chapter 6, we talk about pattern matching as well. Match patterns against literal directly. Following code gives some example. So yeah. Matching named variables. So named variables are irreferable pattern that match any values. And we have used them many times in the book. However, there is a complication when you use name variable in match expressions, because match start a new scope and variable declares part of the pattern inside. The match expression will shadow those that with the same name. Okay. In case with all variables, name x here, and then we have y, but we are using x again here. For me, it's a bit silly. You can change the name, but what if you can't? Yeah, maybe the rustling exercise will try to trick us, and we have to use this. That's why it's good to read this beforehand. Sum 5. Match expression on value x. Look at pattern in the match. Try to figure out the code or print before running the code for. Oh no, I want to print out x here. That's why. Okay. Match y. But yeah, but this one, then y is kind of weird, right? Let's walk through what happened when match expression runs. The pattern in the first match doesn't match the value 50, so it's fine. And then a new variable, not y, we declare. So this will be a new y. So because the match will create a new scope, right? So this y will be another y, not the y here. Beginning with the value 10, new y binding will match any value inside the sum. So this is y equal to 10, but then like yeah, this won't be 10 because this new y, it will match anything, and then this y will become the y happened here. Which is what we have in x. Therefore, so now like we have sum 5, right? So sum 5, so y will be 5 now. New y binds to the inner value of sum in x. The value of 5 is 5. So the expression for the execute and print matched y equals to 5. If x has been a non-value instead of sum 5, the pattern in first two won't match, and I will go to the last. We didn't introduce the x variable in the pattern of the underscore arm. The match will print out default case x equals to none. When the match expression is done, the scope ends, and it go back to the so it ends the inner scope, right? So it go back, and then it will print out at the end x equals to x, and then y will equal to 10. So because like this is a different scope, so it won't match wine. But what if like, oh, I just want to like match anything? So what can we do? To create a match expression that compares the value of outer x and y, rather than introducing a shadow value, we need to use a match guard conditional. Wow. Okay. Sounds fancy. We'll talk about match guards later in extra conditional with match guard section. So there's another session somewhere in the future. Okay, so this is one problem that we may face. Yeah, we can't like really compare 10 to 5 because anything will be here. Multiple patterns. So in match expression, you can match multiple pattern using, oh, I've seen you before. You pop it up before I read it, and then you were tricking me. It was like kind of, is it like, wait, okay. Yeah, we were here at the struct. It doesn't say I have to read like 13.3. I saw you before. We were doing the struct exercise, right? We were doing here. No. Where were we? We saw that before. It's little tiny thing. There's like a pipe operator syntax. Is the pattern or operator, or is a pattern or operator? For example, in the following, okay, we can use an or, so it's either 1 or 2, then we'll print out 1 or 2. We can also use the range, so dot, so 1 to 5, we'll have this. Dot equal, so if x is 1, 2, 3, 4, 5, going to the first so it's kind of like you don't have to type them all out. First one will match. Compiler check the range is an empty compile time, because the only type which Rust can tell if a range is empty or not are character and numeric values. So range are only allowed for numeric or character value, because otherwise we can't, like, there's no way of checking whether it's empty or not, so not allowed. X is C, so it will fall into the first one. Early ASCII characters. Late ASCII characters or something else. Okay. Right. Destruct to break apart values. We can also use pattern to destruct values, enum tuples to use different part of these values. So shows a point struct with 2 views. So again, we have a struct with x and y, and then we can break apart using the matching, the pattern matching, because if we do that, so we have point, we create a p with the point,